This video is to help you with an atom's reactivity. The one thing you need to understand is that in order to determine how the atom is going to react, you need to know how many valence electrons it has. So what I mean by react is that these atoms, they're going to respond to each other. They respond by either bonding or not bonding. That's what I mean by react. So are these atoms going to react or bond, or are they not going to bond? Okay? Now, before we get into... It's 3 o'clock. It's 2 o'clock. Before we get into how they're bond or if they're going to bond, there is one thing you need to know, and that is that every atom wants 8 valence electrons. We call it the magic 8 rule because every atom wants 8 valence electrons. Valence means those electrons on the outermost shell. They want 8. So if an atom has 8 valence electrons, they're happy. But if they have less than 8 valence electrons, they are unhappy. But we're scientists, so we don't say happy or unhappy, we say stable or unstable. So for example, if an atom has 8 valence electrons, it's going to be stable. It's non-reactive. It's not going to bond with any other atom. It doesn't need to because it already has 8. However, if you are an atom that has less than 8 valence electrons in your outermost shell, you're not happy. You are unstable, meaning you're going to react. Because remember, the whole goal is to get 8 valence electrons. So you're going to react with another atom to get to your goal of 8 valence electrons. So if you're unstable, you are reactive. You're going to react or bond with another atom to get 8. All right, let's take a look. So from group 1, need my pointer, group 1, group 2, and then group 13, 14, 15, 16, 17, 18. In order to tell how many valence electrons a group have, you look at the group number. If it's group 1, it's got 1 valence electron. Okay, now let's go all the way to the right. Group 18 has 8 valence electrons, so they are non-reactive. They already have 8 valence electrons in their outermost shell. They're not going to bond with anybody else because they don't need to, so they're stable. But for the other atoms, they need to bond with somebody else to get 8. So group 17 has 7 valence electrons. It just needs 1 more, so it's going to bond with group 1. Easy. Group 17 and group 1, those are your most reactive atoms. They create the strongest reactions. Group 17 and group 1, it's like they're made for each other. Now group 16, you only have 6 valence electrons, right? But you need, 6 valence electrons, and you need 2 more. So they can bond with group 2. Group 15 can bond with group 3, and so forth, right? It doesn't matter who the atom bonds with or what atom, it just needs to get 8. Let's take a look. Here is a sodium atom, and if you look, sodium is found in the very first group. So sodium has 1 valence electron. Now, these empty circles, those represent spaces of where a valence electron could be. So sodium only has 1 valence electron, so only 1 circle is filled in, right? And there's 7 other spaces that sodium wants to fill. Let's take a look at chlorine. Chlorine is over here in group 17, so it's going to have 7 valence electrons, right? So chlorine is only missing 1 valence electron, but sodium is missing 7. So they're a match made in heaven. They're perfect because sodium's just going to put that 1 little electron right here, and boom, they make it 8. So they're reactive. And then sodium and chlorine mixed together, you get sodium chloride, which is also known as stable salt. Let's look at another one. Magnesium is in group 2, so it's going to have 2 valence electrons. Chlorine, we said, is in group 7, so it's going to have 7. So chlorine has 7, magnesium has 2. But 7 plus 2 is 9, not 8. So 1 atom of chlorine and 1 atom of magnesium, they're not going to bond. Let's try hydrogen. Hydrogen is in group 1, so it's going to have 1 valence electron. Oxygen is in group 6, so it's going to have 6 valence electrons. So hydrogen and oxygen, they can bond, right? But oxygen still needs one more valence electron to make 8. So what oxygen can do is just grab another hydrogen to fill both of those spaces. So understand, oxygen doesn't really care how he gets to 8, he just wants to get to 8. So if he bonds with one atom of hydrogen and is still missing one valence electron, he'll grab with another hydrogen. And this is the famous combination you know as H2O, or water. So here's the atom of oxygen with 2 empty spaces for 2 valence electrons. And here comes hydrogen, and hydrogen just kind of insert himself right there. And so now they're all full. Let's try another one. Beryllium. Beryllium is in group 2, so it's got 2 valence electrons. Carbon is in group 14, so it's got 4 valence electrons. So can beryllium and carbon react? Can they bond? The answer is yes, right? But as you notice here, carbon has 2 empty spaces. So carbon has some options. He wants to try to get to 8 valence electrons. He's got several different things that he can do, right? He can grab a magnesium because it's got 2 valence electrons. He can go down and grab a calcium. He can grab a strontium. He can grab a barium, or I can't read that, or an Ra. So he can grab any one of those because they all have 2 valence electrons. Now, another thing he can do, he can grab a sodium, right? He can grab a sodium because that was a valence electron, but that leaves him with an option of another atom with 1 valence electron. So he can grab sodium, he can grab lithium, he can grab hydrogen, he can come down and grab a potassium, he can grab a rubidium or cesium or francium. He can grab any one of these as long as it has 1 valence electron. Understand? Okay, let me reiterate. Carbon just wants 8 valence electrons. He doesn't really care how he gets it or from who he gets it from. He just wants 8. He's going to bond with anything that makes 8, if he can. Let's try another one. Carbon is in group 14, so it has 4 valence electrons. Argon is in group 18, so it's got 8 valence electrons. So are these two going to react? Are they going to bond? No, they're not, because argon has a complete valence shell. It's got 8 valence electrons. It's stable. It's non-reactive. It's not going to react with any other atom. Now, if you look in group 18, every atom has 8 valence electrons except one, and that's helium. One atom of helium only has 2 valence electrons, but why would it be in group 18 with all the non-reactive elements? Because if you remember the 288 rule, the first energy level you can max out at 2 electrons. The first energy level can only hold 2. So helium only has 1 energy level because it's in the first period. It can only have 1 energy level, and on that 1 energy level, he's got 2 valence electrons. So that means that first energy level is maxed out. He's stable, he's complete. So every atom or every element in group 18 will be non-reactive with 8 valence electrons, except helium. He's going to be non-reactive with only 2. Okay, that's it.